Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant and Dave Ansell. Have you got any news about the world of science at the moment, Dave?
Well, NASA has crashed one of their spaceships into the moon.
Wow.
This was deliberate, actually. In fact, it was a few weeks ago they actually did the crashing. This was the L-Cross mission.
Ah, yes.
They basically, they were launching, sending the lunar reconnaissance orbiter up to the moon anyway. And they had a bit of spare mass which they could take there. So what they did was they made a small spaceship and they attached it to the final rocket stage, a Centaur rocket stage. And then they orbited that around the moon a couple of times and then aimed it at the moon and took the spacecraft off and sort of manoeuvred it so it was following the rocket stage. They got the rocket, then they all span the rocket stage around a bit, so it had all been hit by the sun and it dried out completely. The rocket stage smashed into the moon. It made about a 20-metre wide crater and threw up sort of 350 tons of dust and stuff off the moon. Now, this might seem a strange thing to want to do, but this was they hit a very special place, a crater called Cabeus, right on the South Pole. And this crater is always in the shade. Now, normally on the moon, it can get up to 150 degrees centigrade in the sun. And if it gets dark, it's down to up to minus 233, so really, really cold. And what they thought was if they get this crater, which has always been in shade, and I think it's been in shade for billions of years, there might actually still be some water there. And so they crashed it. Actually sending a probe to land on the moon and then dig it up and look for water is actually very difficult. So instead they crashed this rocket stage into the moon. This threw up a huge plume of dust and whatever else was in there, dug this 350 tons of stuff up. And they looked at that using various instruments, and from that they could then work out there was about 20 buckets of water thrown up out of this crater.
Wow.
It's kind of bizarre because the moon is in a complete hard vacuum, and so the water should have evaporated. But because it's been so cold, it hasn't done for billions of years. And why might that be important? It's important because if we ever go to the moon and we want to build a base on the moon, the one thing the moon doesn't have is any water. And the one thing humans need lots of is water. So if we can go and dig it up on the moon, then it might save a huge amount of money, time and energy shipping water up to the moon from the Earth.
Now then, Dr. Dave, let's go to one of our first questions. Mike says, why does ice form in freezers and how does a frost-free freezer not freeze?
Okay, a freezer basically works by pumping heat. It pumps heat out of your inside of the freezer and it pumps out the back. And that's the reason if you've ever been around the back of a freezer, all the pipes you filled and they're really quite hot.
That's why kittens always want to go and get stuck behind them, isn't it?
Lovely and warm, yeah. So the way it transfers the heat is you've got a liquid. Or you compress. The compressor compresses a gas into a liquid. That gives off lots of heat. When you compress a gas, it gets hot. You then cool it down through those tubes. It then comes into the inside of the freezer and it's expanded into a gas again. That absorbs lots of heat. And it is expanded through some pipes inside the freezer. Now, in an upright freezer, they're often in the shelves. You can see sort of pipes inside the shelves. And they get very, very cold, so the coldest parts of the freezer. If you've got any water vapour in the air inside the freezer, it's going to condense, and it will condense on the coldest part of the freezer, so it condenses on the bits which are doing the cooling. And if you keep opening, whenever you open the freezer, more warm, moist air goes in. It then condenses again, and it slowly builds up more and more ice. The frost-free freezers, I think the way they work is every kind of day or every certain period of time, they sort of run backwards and they heat up the cooling elements, and that evaporates off the water or it drips off down to the bottom. And then they turn and they go back to cooling again, and so they never actually freeze up nearly as badly as a normal freezer.
All right, interesting stuff. Now then, Dave, we've got an email here. When I can find it, what have I done with it here? It's from Dave in Great Yarmouth. He says, hi, so I've been recently looking at some magic eye pictures, very popular in the 80s, that somehow turn a flat screen or print appear into a 3D effect. I have even seen a text version that works. How does it happen? How does it occur, Dave?
Okay, to understand how it works, you've got to understand how your eyes see 3D, or one of the ways your eyes see 3D. There are lots of different cunning plans your brain uses to work out depth. But when things are fairly close to you, it uses the fact you've got two eyes. If you look at something quite close to you with one eye, and then shut that eye and look at it with the other, the object seems to move compared to the background.
Oh, yeah.
Yeah. It's because you're looking at it from a different angle. And your brain puts together this information from your two different eyes. It sees the object in two different places, with your two different eyes, and it works out how far away it is. If it's further away, then the movement is less. If you stretch your hand right out to full distance, it should move slightly less.
Yep, I'm doing that now.
And so your brain works out how much the difference is between your two eyes.
I think my brain
and it can work out how far away an object is.
Yep.
Okay, the magic eye pictures take advantage of this. And what they do is they have a background which looks essentially random. They often put patterns over the top of it, but essentially there's no information there, or it's sort of repeating a bit. But, it's essentially random. But if you can uncross... Normally, if you look at something close to you, your eyes kind of are both pointing quite close together, and so you just see something close to you. If you sort of uncross your eyes a bit when you're looking at one of these magic eye pictures, because if you ever looked at them, you've got to do weird things to your eyes to get it to work. If you uncross your eyes... In fact, inside that kind of random pattern, there's two pictures which are offset a bit by sort of maybe a couple of inches or an inch or so. And when you uncross your eyes, essentially your right eye sees one of the pictures and your left eye sees the other one. And your brain all of a sudden puts it together as if it was an object a certain distance away, so you can see depth.
Yep, yep.
And so, because it's if your right eye sees a picture from one place, as if with some objects further to the right than they should be.
Yep.
Left eye sees some objects further to the left than it should be, and you see this beautiful 3D image.
I was just trying that with my hands as you were saying that, because you were giggling as you were answering the question. And yes, it does. I understand that. Dave, I hope that makes it clear for you as well. Thank you very much indeed. Now, Tom in Kings Lynn says, a story in the news this week about somewhere in Galloway being the darkest place in Britain. How do they measure that? And he also says there are places in the Fens which are really dark. I know, Tom. Is it to do with distance from light source or something? How does that happen?
Yes, I think what they're looking at, I think the various places claim to be have the darkest skies in Britain. It's basically if you go out in the middle of the night, you've got a nice clear night. If you're in the middle of a town, because there's so many streetlights shining so much light up into the sky, it's very, very hard to see the stars. But if you're in the middle of nowhere with hardly any streetlights about, then you can see the sky beautifully. I grew up in South Devon, right on the coast, and so there's not many people living there anyway, and you're right next to the coast, so there's nobody to the south, east or west of where I grew up, because I was living on a peninsula, so you have beautiful skies in the winter. And compared to here, you can see hundreds and hundreds of more stars, just because there's so much street lights being reflected off the little bits of dust and stuff in the sky. And so, I think it's probably measuring how dark it is in the how far away you are from street lights. But I think the easiest way to look at it is if you've got a satellite and you fly over Britain at night and take a photograph. Then basically you see all the street lights, and you look for the place with the fewest street lights, and that's going to be the best place to go observing with a telescope.
Absolutely. We must have Dr. Andy Green coming in soon, our director of the Stardome Planetarium. Isn't that great?
It sounds good to me.
It does to me. All right, well, let's go to the phones now, because Bernie is here. Hello, Bernie.
Hello. That's one of the reasons why Patrick Moore chose to live in Selsey.
Must have been.
Yeah.
All right, you're through to Dave. What's your question, honey?
Oh, yeah, it was about... recently someone got nicked in London for a series of crimes, and forensics traced it all down to someone from the Windward Islands. I'm wondering how they get it so accurate and not just say the West Indies as a whole. Any ideas?
I would have thought what's going on is that I guess they had a DNA sample from him or her. And if you look, you can get the DNA, and if you can then, there's a load of, everyone has different genes, but your genes are most similar to the people you're related to. And if you've got sort of groups of people who've basically been living together for thousands of years, then you'll get some sort of peculiarities in their genetic makeup, particularly down the mother's side, because there's things called mitochondria in your cells which actually generate the energy in your cells. And you only inherit those from your mother, so you can follow the maternal line back quite accurately. And I guess they looked at his set of genes and looked at all over the world at the places which most likely have that set of genes, and it happened to be in the Windward Islands.
And with them living on islands, it's less likely they move around than a mainland, say, is.
Yeah, and the other thing, particularly with the West Indies, because it is not a population which has moved around naturally. They've been imported by slave traders. You'll get some islands who've had lots of a population which is based in slaves from one part of Africa. And then you might just sort of economically get another island who was run by the Spanish, and the Spanish imported their slaves from a different part of Africa. So you probably get quite the genetic makeup probably changes quite a lot between islands which are very close together.
Isn't science amazing?
I think so, certainly.
Yes, I do too.
Oh, bless you.
Thank you very much.
Thank you, Bernie. Thanks very much indeed.
Cheers.
Well, we've got Jan in Ipswich on the phone. Hello, Jan.
Hello there.
There, you're through to Dr. Dave. What's your question?
Well, I'd like to know, does the Earth breathe? Because everything on it does, and I wondered if the Earth breathes out oxygen and takes in carbon.
So by the Earth, you mean sort of the rocks, or...?
Yeah, because, even metals breathe, don't they, So, I wondered if I would imagine the whole Earth breathes.
The Earth does, in some senses, it doesn't breathe in the same way as we breathe. It doesn't really get energy because we breathe in oxygen, react it with our food and give it out carbon dioxide, and plants then take in that carbon dioxide and then use energy from the sun to convert it back into oxygen and sugar. So it doesn't breathe in that sense, and it isn't kind of vital for its survival or anything. But it does take in gases and give out gases. Things like limestones are formed at the bottom of the oceans, either without any animals involved, right in deep oceans, or near the surface. Corals and things make limestones, and then when if they're subducted in a subduction zone, then they get taken down really deep. They heat up, and that carbon dioxide from that is breaking off by the heat, and that comes up in volcanoes, and so the gases escape in volcanoes. So the Earth does sort of take in gases get turned into solid objects in the surface, and they get taken in deeper into the Earth. They get heated up and they're released in volcanoes. Okay. And this can cause big things to the climate, because if you get lots and lots of volcanism, you get lots of carbon dioxide released, which heats up the Earth. And so you can get huge climatic changes if you get really big volcanic eruptions. There have been some huge ones, the Deccan Flats in India, hundreds of millions of years ago, and some other ones in Siberia. You get huge volcanic eruptions, and that gives out immense amounts of gases, and that can completely change the climate and causes huge problems for life.
Oh, right.
And there's some thoughts they produce sort of mass extinctions and things. So the Earth can take in gases and give it out, but not quite in the same way as a human.
It doesn't breathe.
It's not vital for its survival. If you took all the gas away, the Earth would still sit there for billions of years perfectly happily.
Right. Okay.
Lovely. Thanks very much, Jan.
Okay.
Take care.
Bye-bye.
Bye-bye. Hello to Brian in Milton. He says, hi, Sue and Doc. Do you know when the meteors are coming through Earth's atmosphere, and are any of them likely to hit us? Ooh, Dr. Dave, that's one for you.
Yeah, we are in a little meteor storm at the moment. In fact, tonight's supposed to be a good night to look for them, the Leonids. That basically means that they look like they're coming from Leo, the constellation Leo. Yep. And basically they're little particles of sand given off by, I'm not sure if they're a comet or an asteroid or something. Basically small particles of dust. They hit the Earth at going tens of thousands of miles an hour. When they hit the upper atmosphere, they heat up, they get very hot, and you get these streaks of sort of fiery streaks. They get so hot. Will any of them hit us? Depends how big the lumps are. Small lumps burn up in the atmosphere very quickly. You've got to have really quite a big lump to get all the way down to Earth. I'm not sure. I don't know whether the meteorites which hit the Earth correlate at all with the meteor showers. Meteorites when they get to the Earth, meteors are when they burn up in the sky. I don't know. I'm guessing they do a bit, but it just depends what hits us. It's purely fluke, basically.
Now, John in Peterborough says he can't talk because he's a baker and the bread's due out the oven soon. But he says where he walks his dog, there are loads of hazelnuts 2 years ago. But there have been none for the last 2 seasons. Why is that, Dr. Dave? Or is it just a load of vegetarians going out collecting nuts for their nut roasts and squirrels and things?
A sudden plague of squirrels. I think it's more likely to be just with the weather, basically. Apparently you do get some effects whereby if you have a bumper crop of hazelnuts one year, then all the small trees take a while to recover, so the next year they're kind of depleted on their resources and they don't produce quite so many the next year. But the major thing is to do with how well they pollinate and what the weather's like when the trees are forming, have flowers. And so if the weather's really bad when the trees are forming flowers and there's not very much sunlight, then they're not going to have much energy to put into making flowers, and the bees aren't going to be out and about, so they're not going to pollinate very many of them. So you don't get very much fruit. And other fruit trees are the same. I know plums, some years you get huge bumper crops and all the trees are falling over because there's so many plums on them. Other years you get virtually nothing. So it's there tends to be a very, very short period when each fruit tree flowers. And if the weather happens to be exactly right, then you'll get loads and loads of fruit. Otherwise, it can be very limited.
Hazelnuts are going to be going up then, it sounds like everything else. Let's say hello to... we've got Ted on the line. Hello, Ted.
Hello, good evening.
Hello there, very good evening to you. You're through to Dr. Dave. What's your question?
Yes, Dr. Dave. I'm standing outside, or not quite. I'm looking at my back door at the sky.
Yeah.
And if I'm not too sure, when I wake up this morning in the early hours with an alarm clock, and I put the radio on and it tells me what's going on in the morning, it wakes me up. And some person was talking about things going on in the sky tonight. And I need to get in a dark sky and look up towards the moon, and there's comets, there's all sorts of things, and I'm standing out here and I can't see a thing. Was I dreaming or was I right?
There should be a meteor shower tonight. The problem with meteors is that quite a lot of them aren't very bright. When they say a meteor shower, they mean you sort of get 1 or 2 a minute. That's a really heavy meteor shower. So you've sort of got to, I don't know, I've watched a couple in the past, and it's not really ideal for this time of year. The best ones are in the summer, because then you can just lie out on the grass and just look at the sky.
That's what this gentleman was suggesting this morning, but it's a bit cool here in Northampton.
Yeah, I think it's going to be a bit cool here as well.
Have you got any binoculars? Because Andy Green, our astronomer, always says binoculars are great for looking at the night sky.
They don't keep you warm, though.
Although they're also not ideal for looking at meteors either, because meteors, they can hit any part of the sky pretty much. Mostly you see them out the corner of your eye. Very rarely do you see them with the centre of your eye, because they're there and gone so quickly that they're really there just in a flash. So I haven't been out. I don't know how good it is at the moment, but it really is a case of just looking out, waiting for sort of 10, 15 minutes at the very least, probably longer, and just looking at the sky and just sort of just looking for things in the corner of your eye, and you just see the odd sort of little streak in the corner of your eye.
Okay, so it's not a big sort of planetarial night then, is it really? The way these gentlemen were talking this morning, I thought it was,
I mean, meteor shooting stars, the same thing. They are cool, and they're lovely to watch. But I mean, yeah, I wouldn't sort of really rearrange your life for them. But yeah, I mean, if you get a dark night and they're quite fun, it's nice to have seen them.
Ted, have you got a nice dark sky where you are in Northamptonshire?
It's not too bad. It's
Oh, bless you. Thank you very much indeed, Ted. Thank you.
Thank you. Bye-bye.
Take care. Bye-bye. Strange one here from Adrian. He says, Sue, how do you make a fake gun into a real one? Is that possible?
It's not something I know about specifically, certainly.
I'm relieved at that.
It depends on the kind of fake gun, I think. It doesn't work. I think it is possible in some very dubious people. I think first of all, it's illegal, so we'll start off with that one, so certainly don't do it.
Yep.
And I think some fake guns are made by taking a real gun and then attempting to stop it, sort of welding it up and making it impossible to fire. And others are just made by taking just random steel and putting it together. If you just got a fake gun, then it's not going to be strong enough, and it could easily explode. If you got one which was originally a real gun and it was fake, then you might be. I think there are illegal gunsmiths who can do various things to make it work, but
You
So
don't
it's
want to be
certainly
doing
legal,
that.
and you certainly don't want to be doing it.
No, you don't want to be doing that. We have more questions. Hello to Max, who says, Dr. Dave, can you explain why wheels on cars appear to be going backwards when they're moving?
You normally only see it in certain circumstances. It's normally when something's flashing. One of the places which is really common is on films or on TV, and very commonly you see wheels going backwards then. The other time is sometimes at night when you're in streetlights, and streetlights actually flash about 50 times a second. And the reason is, if you imagine a wheel going round, and in a light which is flashing, and if and so you won't see the wheel all the time. You only see when there's a flash. And so if you imagine the wheel, if the flash happens once every time the wheel goes round, then you'll always see the wheel in exactly the same place. So it will look like the wheel is absolutely still, because you only see it in the same place in each rotation. Although it's spinning, you only see it in the same place in the rotation once every time, and so it will look like it's dead still. If the wheel is going slightly faster, and so it goes so it does just over one rotation every time, then it will look like it's going forwards, but very slowly. Sorry. And if it's going slightly slower than, so it flashes at slightly less than once every rotation, then the wheel is going to not quite get to where it was last time. So each flash, you'll be able to see the wheel slightly backwards of the time before. And so it looks like it's going backwards. The wheel's still going forwards, but it looks like it's going backwards, because every flash, the wheel doesn't quite catch up with itself. So every time so it looks like it's going backwards.
Interesting stuff. Hello to Sophie, who sent an email in saying, I love the show. Why does water look blue when it's cold and greeny when it's warm? Dave?
I'm not sure. It's an interesting one. Blue water, there's various different reasons why water looks blue. The reason why the surface of the water looks very bright blue is often because the sky is blue and it's reflecting the blue light from the sky. But water is also actually blue. If you go very deep in the sea, then the light which gets down through, the red light tends to get absorbed, and the blue light tends to get and then the blue light will get through. So deep sea fish can normally see blue light but not red light, and some other fish have worked out have got their own red spotlights, and so they can see the world in a colour of light which the other fish can't see, and so they use their red spotlight to illuminate the other fish, and they can chase and eat them while the other fish can't see them. But the reason why warm sea certainly goes green, because you've got algae in it, and so the water, so you've got the warm sea, algae grow really well, so you get green algae in there. I haven't really noticed. I haven't noticed baths changing colour particularly.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.